researchers in Chicago say for the first time they've detected evidence of the brain disease CTE in a living patient. The evidence was found in the brain scans of a former pro football player before he died.
Switch gears to another relevant NFL subject, and that is a new story on CTE emerged this week, and researchers in Chicago published a study in the Journal of Neurosurgery where they performed scans on 14 retired NFL players while they were still alive, and those scans indicated the presence of tau, a type of protein that clumps up over neural cells that have been damaged, and that could be in relation to concussions as well as their playing careers. And to provide more insight on this story, we're now joined by Dr. Eric Nepute of the Nepute Wellness Center, has extensive background and research done in neurological studies, and he now joins us here on the Weekend Playbook. Doctor, Lance Meadow, Jamie Dukes, appreciate the time. How's everything?
First thing I want everyone to understand is this, is that the human body is a self-healing, self-regulating organism. I mean, it's all about self-preservation. I mean, for example, you cut yourself, your body heals. You break a bone, your body heals. You go out and you're working out or you're playing in the yard, what happens to your hands? You get a callus on your hands, right? These are protective mechanisms that the body puts down. You know, when you've got bone spurs on your spine because of degeneration, that's a self-protection mechanism that the body does. The body does this all the time. It's in a constant state of adaptation because the human body, if we don't adapt, we die. So let's talk about CTE, okay? So the term CTE means chronic traumatic encephalopathy. Now, let me break that down. So encephalopathy is a neurological condition that basically means that there's a problem in the brain, and we're having neurological symptoms from it, whether it's depression, insomnia, anxiety, whether it's all kinds of other crazy neurological things that can happen, memory loss, you name it. But I want to break it down even further because let's break it down into a little bit something different. So it really should be chronic traumatic encephalitis, which is an inflammatory process. You guys all know what inflammation is, right? I mean, everybody hears inflammation is the root of all diseases. It causes heart disease. It causes cancer. Inflammation causes pain. It's a problem. So trauma, I need you to understand this. Trauma, obviously, a car accident, a fall. I'm in St. Louis, Missouri, but I manage a practice in Kansas City, Missouri. And Kansas City, Missouri outlawed all of the monkey bars on the jungle gym because kids were having too many head injuries from them. So trauma is trauma. Trauma increases something called inflammation. You guys track me so far?
Yep.
So increased trauma, increased inflammation. So think about this. When you have trauma, when a soft brain hits a hard bone in the skull, that then can cause a concussion. A concussion, the physiology of a concussion is real simple. Increased inflammation, because when you have inflammation somewhere, inflammation at first is a protective mechanism. It takes all kinds of nutrients, rushes nutrients to that area to try to heal it, and then ultimately it tries to pull away the toxins that are causing the problem. So if you have a trauma, you have increased inflammation. The problem is what happens with the concussion is the body also rapidly uses all of its glucose storage to try to repair and work on the brain. The brain needs glucose for healing. That's why when you get a concussion, you can get dizziness, headaches, nauseousness, etc. So what also happens is when you've got that inflammation, all the macronutrients in your body rapidly get used up. So when you have a head injury, a traumatic brain injury, which is also called a concussion, you lose calcium, iron, phosphorus, potassium, magnesium, all go super low because the body needs that to try to repair the brain. So here's where it starts to get crazy. Inflammation, you got to understand this, inflammation is an immune system controlled response. The immune system controls the inflammation in the body. But we have to also understand that the immune system is controlled by the central nervous system, primarily a part of the brain called the parasympathetic nervous system. So when we get too much inflammation, and we've already got a head injury, that's a vicious cycle right there that the brain cannot connect to the body and communicate like it's supposed to. What happens with a traumatic brain injury, a concussion, a fall, falling off a jungle gym, whatever, the parasympathetic nervous system downregulates. Now, that's the part of the brain that allows us to rest, relax, grow, develop, and heal. Okay, that allows our body to heal. So we go into a fight or flight response, which is why post-concussion or post-brain injury, a lot of times people will get anxiety, depression, nervousness, etc. These kind of things can happen. The problem is when it becomes chronic. So now we've got chronic inflammation. And by the way, anything that's over 3 months in nature is considered chronic. So we see this is the problem with a lot of our athletes. It's the chronic injuries that they've got. This chronic inflammation messes up a protein receptor in the neuron. So there's these proteins called tau proteins, TAU proteins, and they're normal proteins that the body produces to try to repair itself. Like if you tear a muscle, your body puts down protein, a specific type of protein, to try to heal it. And usually what happens is that muscle never heals exactly like it was supposed to at the beginning, and we get scar tissue. I'm sure you've heard of that. Well, a tau protein is a normal protein that the brain puts down to try to repair the neurons in it. The problem with this is that when you have chronic inflammation, the tau protein folds, and it turns into a callus. It gets hard. The body's trying to adapt. That's what's happening because it's chronic inflammation. There's too much pressure in the cranium on the brain. The body's trying to adapt to this, and if it doesn't adapt, it dies. And what happens is the chronic inflammation is what causes the proteins to adapt.